Hello.
Hi Rohit. Sorry for joining late. Give me 2 minutes.
No issues.
You can see Sarang joining as well. Let me just add him. Just opening my Jupyter notebook. Give me 2 minutes. Then I can share my screen. I believe you can see my screen now, right?
Yes, yes.
Okay. Give me 2 minutes. I'll just run all the cells once. While the cells are running, maybe in the meanwhile, if anyone has any questions, any queries until what we've done until yesterday, or any doubts, especially on the confusion matrix, ROC, curve, area under the curve.
Yeah, Bhumik.
Yeah, go ahead, Sanak.
Yeah, Bhumik, am I audible?
Yeah, you're audible. Go ahead.
I mean, my voice is.
Yeah.
So I read through this curve. Okay. So
Mhm.
we are basically representing theta through positive rate with the FPR, right? So
Yeah.
I mean, then getting that curve, right? So at
Yeah.
one point, curve gets saturated. It's almost a straight line.
Yeah.
Okay. Yeah. And then there is something called area under curve, which helps us determine our accuracy levels, or let's say how good it is our model,
Mhm.
right? I just needed how we are plotting these points. Let's say, I mean, we have a point
Mm.
called 0, 1 or 1, comma
Yeah.
0,
Yeah.
right? So how we are plotting it? I mean,
Yeah.
we have 1,000 records,
True. Yeah.
okay? And how we are plotting that? Just had that question.
Yeah. Okay. So that's kind of a practical question. I will not answer that. I will actually draw the curve now, which should answer your question. So I will use some functions in Python, and I will draw that curve now. So that's what we need to do now. And then once we draw that curve, right, we will come to know. Looking at the implementation only, we will come to know,
Okay. Okay.
right? But conceptually, you are clear, right? What it is doing and what it is not doing. Hello.
Yeah, Bhumik, you are breaking a bit.
Is it clearer now? Is my voice breaking for you too, Rohi?
No, it's clear for me.
Is it? Okay. Sanax, maybe there is some internet issue on your side because let me
Okay, I
just
think,
quickly.
yeah, go ahead, Bhumik. I think I can
Okay.
hear you.
Okay. Okay, so just to quickly answer that specific question which Sarangs was asking. So we already have a library called Matrix, which we have imported. I believe we have imported Matrix. So in Matrix, in that sklearn matrix, there is a function or a method known as ROC AUC score. Okay, so let's see what this function does. Okay, now what this function does is it is going to take some values. We are going to pass those values. Let's not worry about that right now. But taking these values, okay, it's going to calculate, it's going to compute the area under the ROC curve. So ROC, as we have already defined, it is the receiver operating characteristic curve. And from the prediction scores, it is going to do that. So what I mean by that is, I'm going to write a function now so that I can reuse it a lot more. And in that function, uh, I will pass the actual values as well as the predicted value. Right. So once I do that, it's going to take those values, and for each and every benchmark or each and every threshold value, it's going to find out the area under the curve. So we have to use some kind of a different technique also to plot that. So what we are going to do, we already know. We have let's say matplotlib. It's an easy library to use if you want to do plotting. So I will use that library to find or to plot the values, while I will use this function matrix.ruc AUC score to find the AOC. Right, so area under the curve, I'm going to find it from here for each and every value, and then I'm going to put it in there. Right, there are a few functions that we may want to use, or we are going to use while we are going to call the ROC AUC curve. But as a start, I'm not going to pass anything. Okay, I'm not going to pass anything into this function. I'm only going to pass the first two parameters. The first parameter is y true, and the second is the y score. Okay, so y true, okay, y true is basically, if I scroll up and if I go to my table, okay, the table that I have already created. Okay, let me just do it like this. So this y trend pred final, the data frame that we have already created, has the IDs, the row ID, and then it has the actual value of churn. It has the churn probability, right? And then it has the predicted value along with the cust ID. Cust ID is nothing but the index, right? So ignoring the cust ID, what I'm getting is this churn is the actual churn. This is the churn probability, which is predicted by the model that we have created. It's not the actual probability. So basis this churn probability, we are calculating this number, whether this number is going to be 0 or 1, that's calculated out of this value. So we have written a function also, right? The lambda function that we have written. If this value is greater than 0.5, I say yes, it is equal to 1. If it is not, then it is equal to 0. Clear cut, right? Now what I'm going to do in this core, okay, in this core, I'm going to pass it. It accepts the target scores, right? It accepts the target score. So what it is saying, in the binary or multi-level cases, in our case, that's a binary case. These can be either the probability estimates or the non-thresholded decision values, right? We are going to ignore what is meant by non-thresholded decision values right now, but as of now, we know what is the probability estimate, because that's exactly equal to this number here. So I can pass the y true values, which is this, and the y score value, which is this, for each and every threshold, for each and every row. For each and every row in the data, I'm going to pass the value. When I pass that value, then I will be able to calculate the area under the curve for each and every input I pass, and then using matplotlib, I will be plotting them, right? Uh, let's do the coding, then we will understand how it is going. So I'm going to call my function def, okay, draw, okay, I'm going to draw, hence the name is going to be draw ROC, okay, and clearly this function, I will take two inputs only in this function. I'm going to take the actual and the probabilities. So actual is the actual data or the actual values which I have inside my training data, right? And then the probs are the probability values, right? Then, sorry, sorry, sorry. So now what I would like to do is that, obviously I need what? I need the true positive rate, false positive rate, and the thresholds. Oh, sorry, I made a mistake in the spelling. So these are the three things I will need to do what? To do the uh, to draw the ROC curve. Now, why to draw each and every point, then calculate the true positive rate and false positive rate for each and every threshold? Because we have already seen, right? In the last session, we talked about this, that if I have the probability thresholds ranging from 0.1 until 0.9, I essentially have 9 values here. So I can have a list of 9 values, and then for each and every value, I will need to calculate the TPR and the FPR for the entire data. I know what is the function. I know what is the formula to do this. So using my training data or using my entire data, I should be able to figure these out. That is not an issue. But what if I tell you that there is already a function? If there is already a function, let's reuse it, right? So similar to my ROC AUC score, which was a function in the metrics library, there is one more function which is known as metrics dot r receiver operating curve ROC, okay, underscore curve, CURVE, right? So if I look at the help for this, I can clearly see that it's a function which is computing the receiver operating characteristic. So basically, it's not going to draw anything for me. It is only going to calculate it. Using what? Using it is going to take the actual values and the probability values. I'm also going to pass another function there, which I'm going to tell you about, which is drop immediate. Okay, I'll tell you what this let's say parameter means. But overall, what I'm going to do for each and every combination of thresholds, for each and every threshold and the data, I'm going to calculate the TPR, FPR, and then it's also going to give me the threshold. So in outcome, this when this runs, right, this matrix.ROC curve is going to give me the true positive rate, false positive rate for each of the thresholds for which it has calculated it. And then I'm simply going to use that. I'm simply going to use that, and I'm going to draw the graph, which is going to, I expect it. Okay, I don't know how it is really going to be, but ideal condition, I expected what the point should be as close to the y-axis, and then they should try to converge over to the x-axis and take a parallel line, right? So this is what I'm expecting, right? And this is what I'm going to draw now is exactly what I'm not expecting, right? So any line which is passing through the origin is definitely not what I want. This is really not what I want. The more the line is closer to this origin line is not good, because my objective is this: if I take all the points and join them, my objective is to increase this area under the curve. So obviously, if I have a line which is something like this, then this line's area under the curve, or AUC, is greater than this smaller line's area under the curve, right? So basically what I am doing here is, as you can see, I'm using ROC AUC score to calculate the AUC, or the area under the curve, right? To calculate the area under the curve, I'm going to use this function, ROC AUC score, by using what? The actual values and the probability values. Okay, the probability values, the one which I've used to calculate the predictions. And similarly, I'm going to make use of what? I'm going to make use of the matrix.ROC curve function. I'm going to pass again the same values, the actuals and the probabilities, and I'm going to calculate these points. And once I have got these points and the area under the curve, all I need to do is to plot the points, right? I know what is going to be on the y-axis, true positive rate. I know what is going to be on the x-axis, false positive rate, right? And then I'm just going to take them. I'm just going to take them and plot this. Once I plot this and I also get the AUC, I will get the values of AUC. Now comes the confusion. How do I know that this AUC is good, even after plotting? How do I know that, let's say, this line is what I've plotted? So let me just clear all the drawings. Let's say I have this y-axis and this is the x-axis. And this is my graph that I have plotted. This is the bad line, okay? And my AUC is having some value, okay? I have some value of AUC. How do I know that that value is really good or that value is really bad? I don't know that. Okay, nobody knows. Nobody really knows that. Really, nobody knows. What we have to do is to maximize. Okay, we have to maximize our specificity and sensitivity. So if we are able to maximize our specificity and sensitivity in a certain model, let's say we are creating model 1, in that model, my AUC should be such that I am able to have a very good or a very decent value of the sensitivity and the specificity scores. Again, this comes to a question: how do you know which value is good? You don't know that. Nobody knows. That's the reason why you create multiple models. You don't create model one. You create model one. You create model two. You create model three. You create model four. You create model five. For each and every model, you find out the sensitivity, the specificity, the ROC curve, and hence the AUC. Now you do a comparison. Which model do you think is better, right? Or what you can do, if you are only going to play around with one model, for each and every model you will have to do this. For each and every model, what you have to find out is the threshold. Okay, the value of the threshold being 0 0.1 or 0 0.2 until, let's say, 0 0.9. For each and every value, what was my AUC? Right, this gives me the idea that, okay, maybe or most probably a threshold of, let's say, 0.8. Let's say this is 0.8. So a threshold of 0.8 is good for model 1, because out of all these findings, it is giving me the best results. Right, so for our model that we have already created, this is exactly what we are going to do. We are not going to touch on this point. We are not going to touch on this point right now, because there will be other techniques like uh, bootstrapping and random sampling and random search cross validation and so on, which we are going to do when we are going to do the classification algorithms. Methods of random sampling or bootstrap sampling is going to give us better sampling distributions, or uh, 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 as less bias as possible in my samplings or in my samples, which we are going to use. So when we use those, then we will look into this technique, right? But as of now, we will only learn how to calculate this curve, how to draw it, sorry, how to calculate as well as draw, and then calculate AOC, and then create a table which is similar to this. Let's see if we can create a table like this. Then we'll find the threshold, we'll find the most appropriate threshold, and then we will see how my model is really performing on that threshold, right? Any doubts here? Any doubts until this point? Any doubts, friends? Okay.
No more.
uh, I'll take that as a no, and
Getting clear.
okay, I'll take that as a no.
Picture of
And
zero, one, 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 one in the end.
sorry, I'm sorry, Sanaksh, I didn't get you if you are speaking. Okay. Uh,
No, no, honest speaking. I
okay.
think there's
Okay.
some lag.
Yeah. Then let's try to continue. Then what I'm going to do, obviously, model ROC curve. This is the function to calculate the points, not to draw, only to calculate. So ROC underscore curve. What I'm going to pass actual and probes. Okay. These are the two things which it needs anyway. Okay. This is what it needs. I'm also going to pass a value to a parameter drop immediate is equal to false. I'll explain this at a later stage. Let me first complete the drawing. Oh, sorry. By mistake, I scrolled down. Sorry. Right. So now when this line executes, I have got the true positive rate, false positive rate, and the threshold. So for each and every threshold, I have got this. Now what I need is my AOC score. I need the total AOC score of my model. So of the current model. And what I am going to do that is that I'm going to call this function, sorry, matrix dot ROC AOC score. And again, I will pass actual and probes, right? If I do this, my job is done. I have already calculated things. I don't need to do anything more. Okay, to be very honest, I don't need to do anything more. I have already calculated this thing. I really don't need to do anything, right? But I would actually like to plot this. Okay, now if I have to plot this, what I am going to do is that, let's say I would like to plot uh, the I would like to use a matplotlib. So plt.plot. This is the function which I'm going to use. Inside the function, what I'm saying, I want to plot the false positive rate, which is my x-axis, against the y-axis, which is my true positive rate, right? I'm going to give this a label. This plot will have a label. Okay, I'm going to give it a label called ROC curve. Sorry, curve. Okay, this is the label I want. And uh, here I would like to give this area as a value. So I would like to print the AUC value. So what I'm going to say, area, okay, area is equal to percentage 0.2f. Right, this is something which we have not seen earlier. The syntax looks similar to C language, right? The syntax looks similar to C language if you have worked with C language, but this will be very clear soon as I complete this line. So what I'm doing here is basically this is going to be the label of my graph, where this percentage 0.2f means two places of decimal represent AUC score as a fraction. So represent AUC score as a fraction, okay, in the outcome graph as a label, print the AUC score up to two places decimal, right? Now my job is almost done. Now what I need to do is that I just have to figure out the ways I'm going to plot them, or the scales. So what I'm saying, plt dot plot, obviously the scale for false positive rate and true positive rate is going to be within the range 0 1 0 1, right? I would like to limit them, or I know that they are going to be between this range, so I'm specifically mentioning it. Okay, I'm specifically mentioning it, and I'm also mentioning that for the line, okay, the line that I'm going to draw, okay, the line that I'm going to draw, I'm going to use a line style which is k hyphen hyphen. So this means, okay, this line that I have written over here, let me just do this like this. So I'm going to put some comments over here. Otherwise, we wouldn't be remembering. Calling a function to get the actual true positive rate, false positive rate, and thresholds, threshold values. Okay, we are going to play with the threshold staple later. First, let's plot it. Okay, now calculating in this line, what you are doing, calculating the AUC score. Then in the next line, what are we doing? Plotting the ROC curve. Only we are plotting the ROC curve. That's all, along with a label to show the AUC score or the AUC value, right? Area under the curve I'm showing. This fourth line, what am I doing? Here we are plotting the bad line, right? This is the terminology that I have given. This is not a mathematical thing. I call that a bad line because more close to that line you are, the bad your model is, right? We have to be away from that line. So that's the line that has a 45-degree angle, right? The one which passes through the origin. So that is what we are plotting over here, right? That's what we are giving it a coordinate of 0 to 1 0 to 1 and a style of hash or dots, right? Now I'm going to give it the labels, or I can also give the limits and things. So I'm going to give some limits now, setting the limits to the x and y axis. So what this means is plt dot x limit. Okay, the limit of x. Okay, x is going to go from a range of 0.0 until 1.0. Let's say, right? Because I know it's going to be within this range. Then why am I really specifying this? It's really optional. If you want, you can, or otherwise the graph is going to be plotting it anyways, right? Now what I'm going to do, very interesting thing, I'm going to not limit y to 1. I'm going to limit, or I'm going to display until 1.05 value in y, so that I can clearly see where the curve is merging. So what I mean by that is, ultimately I'm going to have an output which is like this box, where this is going to be my y-axis, this is going to be my x-axis, and I'm expecting a curve which is something like this. Okay, this value is 1. If I don't put some buffer over here, it's going to, this line will touch with this line. So I will not come to know how good or how bad it is clearly. And then I'm also drawing, okay, I'm also drawing, how can I change the type of the line? Yeah, I'm also drawing a line which is something like this, right? So that's what I have done until now, right? This is done. Now I can give giving labels to axis. This is also an optional thing to do. If you want, you can do plt x label. I'm going to say this is what x on x. What do we have? On x, we have the false positive rate. right? On X we have the false positive rate, so we have FPR. Okay, on PLT Y label, sorry, label, we have the true positive rate. This is on the Y axis, right? Done. Anything else we can measure? We can do one thing that is something that I prefer doing in case we are drawing the ROC curve. Usually what happens is in matplotlib, like the legend always comes on the top right corner, but I want to see the converge. I want to see that curve going smoother at its tail. So that is the reason why I would like to mention the legend location. And we can do that using this legend. There is a function called a legend, and here I'm just going to say that the location LOC, okay, of that legend, okay, the location where it should be printed, it should be lower right. Okay, you can find these kind of things from the documentation because I've used it earlier. That's why I know. Now I'm going to do, finally I'm going to do plt.show. So in this line, what I'm doing, I'll just write it over here again. I'm just placing the legend. The legend shows what? Showing the AOC score, right, at the lower right corner, right? If I print this, it did not show anything, and I don't know why. Yes, I have not called the function. I've just created the function. It is not going to show me anything. I have to call the function, right? Then only it's going to show. So what I'm going to do uh, is that now I'm going to call the function. Let me just see. Yes, I have made a mistake. This is intermediate, not immediate. Very silly mistake. Now I'm going to call the function also, and I'm going to calculate the FPR, TPR, and thresholds also. Okay, I will calculate FPR, TPR, and thresholds separately because I need to draw that table thing, right? So let me just copy paste this line because I know using this line I can calculate them. So I'm going to put it over here. Sorry, I think I used the wrong keyword thing. So I will take this over here and I'm going to say model RBC curve in actual and probs. What I'm going to pass in actual, I can pass my Y train pred final dot churn. Is that the column? Let me quickly confirm. Yeah. So yes, Y trend pred final churn is the actual value. Okay. And then I'm going to pass the probability. What is the probability? Churn prob. Right. Churn prob is the probability. So I will copy the entire thing from here. Y to type. I'll do it here and I'm going to say this churn prob. Right. I should be able to get the values. Model is not defined. Oh, sorry. Obviously, model is. This was a good identification, otherwise I would have done the mistake there also. So metrics, yeah. Is there now? So TPR FPR threshold, it's already calculated. We want to see the value looks like this. It's actually a range.
Right?
Sorry Saransh, we cannot hear you. Maybe I'll write on the chat window because I'm not able to hear him at least. So let me just yeah.
Yeah, Mohammed, I think I'm facing some network issues. It's fine.
Yeah. No problem, Saransh. Maybe you can try to rejoin or we can discuss the doubts after the session. Yeah. So TPR, FPR, and the thresholds, we have got them now, right? But how are we going to convert that? How are we going to convert that into table? We are going to look later. But interestingly, we have done something interesting. We have to draw that ROC curve first, right? So I'm going to call that function first, and then we will see how to formulate the tables and so on. So obviously, that function is asking for the actual value and the probability value. That's exactly what I'm going to pass. Hopefully, if I'm done everything right, things will be printed like this. But I think I have done a mistake because the graph should not be like this, right? It should be the opposite. Why is it giving me um, a value which is something like this? There is some mistake, I believe, that I have done in my function. Let me go back and see. Let me go back and see what I have done. I am plotting FPR. Oh, very bad mistake. FPR comma TPR, I wrote it in a different way. I did the same mistake here also. FPR comma TPR. Very silly mistake, friends. These are kind of things. Let me close this. FPR threshold. Very good. Let me draw this now. Yeah, good. Now we have the curve and we know the value. See the area under the curve. It's 0.85. I have told you what we don't know. We don't know whether this value is good or bad. We don't know that. We just know that we have a model which I have for which I have got the actual values and I've got the predicted values. I pass those values in that function which I write and I get the ROC curve. So specifically, I hope you can understand this now. This is true positive rate. This is the false positive rate. This is the area under the curve, which means this is this area, the one that I'm specifying now using the red color, right? This is the bad line. Okay, this is my bad line. This is the line I don't want. And this curve is my ROC curve, right? This is my ROC curve. And this is my area under the curve. So I would like to find out for which threshold, okay, for which threshold, which particular value of threshold do I get a good combination of sensitivity and specificity as obtained from the true positive rate and the false positive rate, right? If I'm able to find that, then I can improve my model. How? Because as of now in my model, I have selected or I have specified only the de facto threshold of 0.5. Obviously, that's the standard thing. Now, 0.5 may not be the right thing to do. So that's what we are going to find out now. Then let's see which value really becomes our threshold. So, okay. Now, let's write some code here to draw the table. I hope until this point in time everything is clear. But if anyone has any questions, please stop me there, friends. Right. So now we are going to find the optimal cutoff points. Right. Now for that, what I'm going to do is that I will first of all create a list of numbers. Okay, I'm going to create a list of numbers, and this list of numbers is going to have what? Those nine numbers starting 0.1 to 0.9. Now, why to write them if I know I can do a lambda function? So I'm going to say float of x divided by 10 for each x, okay, for x in a range of 10, right? If I print numbers, if I print numbers now, and I could see I have got a list, okay? Starting from 0.0. So I'm actually taking a range of 10 numbers starting from 0.0 until 0.9, right? Now what I'm going to do, I can do a looping for any value I in numbers. Okay, show me a table, okay, or to give me a table where I'm going to say y train trade final. I can just add this value, okay, in my table only. In my table only, I am adding that value, and I'm going to say, okay, that value or a column of that value is going to be y train pred final, okay, and I'm going to calculate what churn probability, churn prob. From churn prob, I'm going to do the calculation for that value. I'm going to say a map, okay. I'm going to say a map, and here in the map function, I'm going to write lambda function similar to earlier, lambda x, where x is 1 if x is greater than I, else 0, right? If there is any doubt on this, please look at the code. Well, I think no, but there should not be a problem with the bracket, right? Why is there a problem? Churn prob map lambda x equal to 1. Oh, ho. Sorry. If this should be if, right? So for each number, I'm adding a column in the y train pred final dot head. If I do, I'll see now I have added a set of 10 columns here. Each column specifies me a threshold, and for that threshold I'm trying to find out what is the prediction value. Okay, what is the prediction value? The final prediction value using 0.5 that I have got is 0, right? But if I had used a threshold of 0.0, I would have got a value 1. For 0.1, I would have got a value of 1 in this case. So let's take one example. Okay, let's not get confused. Let's take one example. So let's say for this customer ID at 98, actual value is 1. The probability percentage as per our model is 0.42. Uh, and what we predict using a 0.5 threshold is this. So this value that we have over here is using a lambda function which we have done earlier that uses 0.5. If we had used 0.0, it would have been 1. 0.1, it would have been 1. For 0.2, it would have been 1, and so on and so forth. So that's each and every row that means. Okay, that is the meaning of each and every row, right? This is what we have calculated. So we can use this kind of a cross table to find out what is our best threshold, right? I hope there is no doubt here. I hope there are no doubts until this point in time, because now we are going to calculate a data frame which I'm going to call cutoff data frame, right? I'm going to calculate the values inside a data frame known as cutoff data frame, and I'm going to create I'm going to say this is a PD data frame where in brackets I'm going to say columns is equal to, I want 4 columns. Okay, I want 4 columns in this data frame. The first column should be, let's say, my probability or my threshold, right? So I'm going to call this prob as of now. It can also be read as the threshold, right? Then I'm going to call the next column as accuracy. The third column I'm going to call sensitivity, right? And the fourth column, sorry, the fourth column I'm going to call it specificity, speci, right? I'm just giving some smaller names so that it is easier for me to understand, right? As of now, the data frame is blank, but using this cross table, I'm going to fill up this table. I'm going to calculate uh, the things which we did for confusion matrix, right? I calculate the confusion matrix. I take the things out of there. I calculate the specificity. I calculate the sensitivity, and then I assign the values in each and every cell, in each and every row, right? For each and every row, I assign the values. And finally, I'm going to print the data frame. And then I'm going to get for which threshold I will get the best accuracy of my model. And for that accuracy, which is the best, how much sensitivity and specificity will I get? So obviously, I am not going to go with the accuracy value. That's not the objective, right? I have already told you earlier, why are we doing this exercise? Is because we don't only rely on the accuracy percentage. We have also to consider the specificity and sensitivity. So we take the model, okay, or we take the threshold value where we have a very good or handsome values for both sensitivity and specificity out of the range that we are going to find now, along with the accuracy of the model, right? So I am not looking for a 90-95% accurate kind of a model. Maybe with this data I wouldn't get it, because we have already seen, we have done all we could do, but we still have an accuracy of 80%. Maybe that's the max we will reach, which is fine. Even if I have a model with 72% accuracy, that's also okay. But the model with 72% accuracy should have very good or comparable sensitivity and specificity. When we get the output, then I will explain what do I mean exactly by comparable, right? So I have got the numbers. Okay, I have got the numbers. I think the numbers are there. Yeah. So what I am going to do is that now I am going to calculate the confusion matrix. I believe the confusion matrix is already imported from SQL, and I think confusion matrix I printed right earlier. Let me see if I have the library, because then I don't have to calculate, right? Yeah, it is there. It is there. Matrix dot confusion matrix is there. Very good. So I'm going to use that function here, right? So just to clarify things, let me just clarify some things. True positive is what? If I have a confusion matrix, okay, if I have a confusion matrix with the name confusion, okay, then the value at cell 1 1 is the true positive, right? Value at cell 1 1 is true positive, okay, where both of them are 1, right? The actual and the predicted value. True negative is what? Confusion. in the confusion matrix named the confusion, whatsoever is available in 0 0, right, which means actual is also 0, predicted is also 0, right? Then I have false positive. False positive is confusion matrix where I have 0 comma 1, right? And false negative is going to be 1 comma 0. So confusion 1 comma 0, right? um, Not sure why this printed it like this, so why don't I just put a line over here? Maybe that will help. Let's see. Yeah, so this is what it is, right? So if I draw a confusion matrix, these are the terminologies. I just wrote it down so that I can refer to it, and I can also calculate the sensitivity and the specificity, right? Now what I'm going to do, sensitivity specificity is going to be what, 0 comma 0, true negative, right? And sensitivity is my true positive, right? So using the true positive in the numerator, not only the true positive. So how am I going to calculate? I have the numbers list, so I'm going to loop through them. For I in numbers, okay, for I in numbers, I would like to know what is confusion matrix in cell 1, or I would like to calculate a confusion matrix C1 using matrix dot confusion matrix. Okay, this is a function I'm going to use to calculate it. And what am I going to pass? Y train pred final dot churn. This is the actual value, and I'm going to pass the cell number. Okay, I'm going to pass the act or the predicted outcome. How do I get the predicted outcome? I get the predicted outcome from Y train pred final cell I, right? Because in cell number I do have what? If I is equal to 0.0, I have the predicted value in that cell number, right? So that's exactly what I'm doing. Okay. So I'm passing that value. For example, for value 0.2, I am passing 1 and 1, right? And then I'm going to calculate the confusion matrix. So for each and every cell, I'm going to do this. That's why I'm doing it like this. Now what I'm going to do, I'm going to take a total. Let's say that is total 1. A total 1 is going to be sum of, okay, sum of all the confusion matrices sum. So I'm going to take CM1, right? Once we are done with it, we will be clear. Now I'm going to calculate the accuracy of my model, which is the accuracy of that specific value, which is going to be what? Accuracy is given by true positive plus true negative, right? True positive plus true negative divided by total. So true positive is CM1 0, 0. No, this is true negative, and true positive is CM1 1, 1, right? This is what we have got from the table above. That's why I wrote it there, so that I don't make any mistake. And then I divide it by total 1, right? I'm going to divide that by total 1. I'm just going to put this into bracket just to avoid any BODMAS rule or calculation errors. So in the numerator, I have what? True positive and true negative, and dividing it by the total 1. Total 1 is one sum of all the values which are there in the confusion matrix for each and every value, of in numbers, the thresholds that we have already got. Now we have to calculate the specificity and the sensitivity, right? We have to calculate the specificity and the sensitivity for each of the threshold. So for each of the threshold, specificity is going to be what? True negative. Okay, specificity is going to be true negative. So this is 0, 0 divided by, okay, divided by true negative plus false positive. So CM1 0, 0 plus CM1 0, 1. Right? Have I done it in the right way? No, I have done a mistake. I shouldn't have given it over here. So I don't need that bracket there. Right? So this is the formula for specificity. Specificity is what? True negative. Yeah, true negative divided by true negative plus false positive. right? So that's my specificity. Sensitivity, I'm not going to type. I'm just going to do a copy paste now. Sorry, give me 1 minute. Right. So for the sensitivity, what we are going to do, sensitivity formula is what? Uh, Very simple. On the numerator, I'm supposed to have the true positive. So this will be 1 comma 1. In the denominator, obviously, I'm going to have 1 comma 1, and I'm going to add that with 1 comma 0. Okay, 1 comma 0 is my false negative, right? So false negative is what I'm going to add. Those are the two cases. So I've got the specificity, I've got the sensitivity, right? I've got the accuracy, and I know the threshold. So what I'm going to do in my cutoff data frame on position number I, okay, on position number I, or I'm going to specify this using my log function, okay. On position number I, you will come to know what is the meaning of the log function. Now, on position number I, I'm going to print the values which I need in the data frame, right? The values which I need in the data frame is, first of all, I need the value of I, then I need the value of accuracy, then I need the value of what? Uh, Sensitivity, then I need the value of specificity, right? I believe that should do my job. Now, let me print cutoff df. If I do a print of my cutoff df, I have calculated for each and every probability, or each and every index, or each and every threshold. I've calculated the accuracy of the model, the sensitivity of the model, the specificity of the model. You see, there is a very clear trend over here. Okay, let's try to understand the trend. As I increase the threshold, my sensitivity decreases and my specificity increases. Are you getting my point? As I increase the probability or the threshold line, forget the accuracy right now, the sensitivity is decreasing while the specificity is increasing, right? So that is property number 1. Property number 2, I'm going to clear all the drawings, and this is going to be a question for both of you, if you both can still hear me. Which value, okay, which value of threshold are you going to vote for, keeping in mind all the 3 parameters: accuracy, sensitivity, and the specificity? Let me just zoom the screen so that you can see it clearly, right? For which value of threshold would you vote? Any suggestions, Rohit, Saransh? I hope you both can hear me still, right?
Yes, yes, we can hear you.
Okay. Any idea then which threshold should I pick? Because if you look at this table, 0.5 is the one where I have highest accuracy. But 0.5 is not where I have very good sensitivity, or I have very good specificity. So the balance is not right over here. If you look at this table, the balance is right at only one place, and that is this, right? If you take a threshold of 0.3, my model will have lesser accuracy, but it will have a very handsome sensitivity as compared to the specificity. So the balance between sensitivity and specificity is really going to be very good. If I select my threshold as 0.3, for any other threshold, in my table, this does not match. Okay, this does not work, which means I should go ahead with this for my model M1. So I've created my first model M1 for which my threshold value becomes 0.3, right? I hope that that point was clear. Let me just clear all the drawings. Okay, let me,
Can't we take the 0.41?
why 0.41? Can you justify why you think 0.4 will be good?
It is more accurate and the sensitivity is comparatively a bit lesser than that of that.
Yeah, but we
And
need that to be equal, right? So sensitivity is what? How much good you have correctly identified the true out of the possible true points, and specificity is what? How much correctly you have identified the false out of the possible false, right? If you see over here for 0.4, the falses you are trying to classify, they are on the higher side as opposed to the true ones, right?
okay, yeah,
Right?
got it.
Even if you have got a higher thing here, so both has to be in the balance. That's the point here. Okay, so we have
Yeah,
got
got it.
0.3. So let me just zoom out a little bit. Otherwise, not sure what is happening with my notebook. It is going slower. So let me just zoom out. I'll just save it here. And now I know that 0.3 is good. Okay, so 0.3 is good. One more very important or a very intuitive way to do this. I'm going to show this, and I'm sure you are going to love this. So cutoff df, I can do a plot directly on the data frame. I'm going to say plot using a line chart, and in the line chart, give me x being a probability column, and y. Okay, give me y as a list. Okay, or multiple columns, which is my accuracy. Then I have my specificity, or I'm going to say sensitivity, and my specificity, right? And then I'm going to say PLT dot show. If I do a PLT dot show, this is what it does. And exactly what we need to do now, this is more visually clear. You have to find this point. You have to find this point. The value for this point is what we have to find. If I draw a line like this, is clearly it is something closer to 0.3, not exactly 0.3. It may well be 0.34 or something, right? It may well be 0.34 or something. So I hope you can understand where we can improve our model. So where we can improve is in this case, right? I can try to divide it by 100. I can try to divide it by 100 and take a range of 10, then I'm going to get a lot of threshold values. And from that threshold values, I should be able to clearly find out from this table for which exact threshold value in two places of decimal in that case, where do I have good accuracy as compared to sensitivity and the specificity, right? But let's go ahead with a ballpark number. Let's say that number represents 0.3. So I'm going to go ahead with 0.3 only. So if I'm going to go ahead with 0.3, let's just update my, what was my Y train pred final, Y train prediction final. And I'm going to say final probability. Final probability, is that going to, no, final predicted. That's a good name. Final predicted is equal to y train pred final. And I'm going to write again lambda function, lambda x, okay, to be 1 if x is greater than what? 0.3, else 0, right? Because I've selected 0.3. I've selected a 0.3 as my, I've selected a 0.3 as my threshold. So if I'm going to do that, there is some mistake I have done. Let me just see what mistake I did. Is there any? Oh yes, of course. Uh, prob dot map. I have to put it inside a map function, right? List is not callable. Why is list not? Oh, I don't need this bracket. I'm making some silly mistakes today. Anyways, I got the output. Read final dot head 10. Oh, sorry. Let me just do head 10. If I do ahead 10, then I get the predicted values. Now I have quite good results. If you look at these 10 values, I see only two misclassifications. Only two misclassifications I see. I see a misclassification here, and I see a misclassification here. Okay, I see two misclassifications. Obviously, that's not going to be a problem because we know, right? We know that we have selected the accuracy model in such a way only that uh, uh, that we wanted to elevate the points, right? I mean, we wanted to find out the best possible value, right? Now what we can do is that we can try to make the predictions on the test set. So we are ready with our first version of the model. We're not going to create multiple models right now. As I said, we would have to look into the concepts like how we can do the random sampling of each and every parameter that represents a model. We may not be doing that using a logistic regression. We will be doing it more with the other classification models. So when we do go there, we are going to look at the methods like random search, CV, and so on. So in that case, we will end up creating 5 or 6 models using a loop, and then we find out the best parameters of the best model. Then we create that model and finalize it. So as of now, we have reached a stage where we have done some predictions on my training data. I've got some accuracy on my training data. Now I would like to look at the testing data, and I would like to do the actual prediction and see how much my predictions are, or how good or how bad they are with respect to my final or my testing data, right? So if I do that with my testing data and find out how much accurate my results are, or what is my sensitivity, what is my uh, uh, specificity, I should be able to understand how good or how bad this model performs on the training set as opposed to the testing set, right? But most probably we can do that in the next session. We can take a logical stop now. I'm going to stop the screen sharing now. I hope that was informative. If you have any queries, friends, please do post on the group. I'm going to share the code soon. Thank you so much.
Thank you. Good night.
Thank you. Thank you, Sarangs.
Thank you, Bhavin.
Thank you, Rohi.